Chem Mastery, your study buddies.
Welcome back to our video. We will discuss the answers of tutorial questions which we have given last week. Let us look at question 1. Question 1a requires us to explain the position of R in the periodic table, while question 1b is to explain how the compound is formed. By looking at the electron arrangement of R, there are 3 shells, 8 electrons at the outermost shell and charged with -1. 3 shells mean that R is from period 3, while the charge -1 means the R is from group 17. Therefore, R is located at group 17 and period 3. Since the compounds are with charges, this is an ionic compound. To explain the formation of ionic bonds, first we need to state the electron arrangement of Q and R, and then explain how they achieve stable electron arrangement. The electron arrangement of atom Q is 2.8.8.2. Atom Q has to lose 2 valence electrons to achieve the stable octet electron arrangement, which is 2.8.8. Then a cation Q2+ is formed. The electron arrangement of atom R is 2.8.7. Atom R has to receive 1 electron to achieve the stable octet arrangement, which is 2.8.8. Then an anion R- is formed. A Q2+ ion and 2 R- ions will be attached together by strong electrostatic forces. To answer question 1c and 1d, we need to understand the formation of covalent bond and the differences between ionic and covalent compounds. To answer question 1c, we know that atom R needs 1 more electron to achieve stable electron arrangement, and also carbon atom needs 4 more electrons to fulfill the octet rule. Therefore, 1 carbon atom will combine with 4 atom R. Therefore, 4 single covalent bonds are formed. So the formula of the compound is Cr4, and then this is the electron arrangement of Cr4. We know that compound B is an ionic compound, while compound C is a covalent compound. In terms of melting point, compound B has higher melting point while compound C has lower melting point. It is because compound B consists of negative and positive ions, which are held together by strong electrostatic forces. More heat energy is required to overcome the strong forces. Compound C consists of molecules which are held together by weak intermolecular forces. Less heat energy is required to overcome the weak forces. In terms of electrical conductivity, compound B can conduct electricity in molten or aqueous state because of the free-moving ions. Compound C does not have free-moving ions, so it cannot conduct electricity in any state. Here's another question related to the ionic and covalent compound, and also the dative bond. Please have a look at the questions. The identification of elements by looking at the electron arrangement is very simple. The info we can obtain from electron arrangement are the number of shells and the number of valence electrons. By referring to the periodic table, I believe that you all can identify the elements. So, Q is oxygen, R is aluminium, X is argon, while Y is carbon. For the formation of ionic compounds, we need a metal and non-metal. From the question, aluminium and oxygen are the most suitable elements to form ionic compounds. For the formation of covalent compounds, we need non-metals. Since argon is inert, carbon and oxygen are the most suitable elements to form covalent compounds. Now, we will proceed to question 2c. Since dative bonds only exist in covalent bonds, we should focus on carbon and oxygen. Carbon monoxide is formed when 3 pairs of electrons are shared between carbon and oxygen. We need to know where the sharing electrons come from. So, Lewis structure is useful in determining the dative bond. Carbon atom has 4 valence electrons, while oxygen atom has 6 valence electrons. The black dots are valence electrons for carbon, while blue dots are valence electrons for oxygen. We can see that one of the bonds consists of 2 blue dots, meaning that the 2 electrons of the bond are coming from the oxygen atom. Therefore, oxygen atom is the electron pair donor, while carbon atom is the electron pair acceptor. So, the bond is a dative bond. Next, these questions are about the metallic bond. The first question asks the definition of metallic bond. Metallic bond is the electrostatic attraction between the positively charged metal ions and the sea of delocalized electrons. The second question is also simple. The physical properties of metals are good conductors of electricity and heat. To answer this question, we need to understand the factors that affect the strength of metallic bonds in metals, which are the number of valence electrons and atomic radius. Potassium has a lower melting point than aluminium. The difference in melting point is because potassium has a weaker metallic bond than aluminium. The strength of a metallic bond is proportional to the number of valence electrons and inversely proportional to the atomic radius. Potassium has a smaller number of valence electrons and a larger atomic radius. Next, we will answer question 4. To answer this question, we have to know what is the difference between hydrogen bond and van der Waals forces. The ascending order of their boiling point is CCl4, NH3 and H2O. CCl4 is held together by weak van der Waals forces, but H2O and NH3 are held by hydrogen bonds. CCl4 cannot have hydrogen bonding because there is no hydrogen and highly electronegative atom in CCl4. Hence, CCl4 has lower boiling point than NH3 and H2O. Now, we compare the hydrogen bonding of NH3 and H2O. The strength of hydrogen bonding depends on the number of hydrogen bonds that can be formed in a molecule. Each nitrogen atom in a NH3 molecule has only one lone pair of electrons and can form only one hydrogen bond, whereas each oxygen atom in a H2O molecule has 2 lone pairs of electrons and can form 2 hydrogen bonds. Therefore, the strength of hydrogen bonding in water is greater than that in ammonia. Thus, H2O has higher boiling point than NH3. Now, we will proceed to question 5. Question 5a requires us to state the name of element X and the type of bond formed based on the information given. Question 5b asks us to choose 2 elements that form a compound with a high melting point and high boiling point, and then explain the formation of the compound. For question 5a, since the compound does not conduct electricity in all conditions, it is a covalent compound. Therefore, element X is carbon and the type of bond is covalent bond. For question 5b, we have to list down the electron arrangement for all the elements. Since the compound form has a high melting point and high boiling point, the compound is an ionic compound. There are 2 combinations that can be formed from the elements given. You can just explain one of the combinations since the question is asking for one compound. The first combination is Q and R. The electron arrangement of element Q is 2.6, and then the electron arrangement of element R is 2.8.8.1. Element R donates 1 electron to achieve the octet electron arrangement and forms R+ ion. Element Q receives 2 electrons to achieve the octet electron arrangement and forms Q2- ion. Therefore, 2 atoms of R will react with an atom of Q to form an ionic compound with the formula R2Q, that is held by strong electrostatic forces. The other combination is Q and S. The electron arrangement of element Q is 2.6. and the electron arrangement of element S is 2.8.8.2. Element S donates 2 electrons to achieve the octet electron arrangement and forms S2+ ion. Element Q receives 2 electrons to achieve the octet electron arrangement and forms Q2- ion. Therefore, an atom of S will react with an atom of Q to form an ionic compound with the formula SQ that is held by strong electrostatic forces. For extra information, the electron arrangement for element P is 2.4. This element usually forms a covalent compound. Next, question 6a gives us a table that shows the properties of ionic compounds and covalent compounds. We have to complete this table. The state of ionic compounds at room temperature is solid. It is because it has strong electrostatic attractive forces between the cations and anions. The melting point and boiling point of covalent compounds is low. Ionic compounds are usually soluble in water but insoluble in organic solvent. It is because of the interaction between ions and polar water molecules. Lastly, covalent compounds do not conduct electricity in any state. The next 3 questions for question 6 require us to explain the difference in the electrical conductivity of ionic and covalent compounds, difference in the melting point and boiling point of ionic and covalent compounds, and state the uses of covalent compounds as solvents. For question 6b, ionic compounds can conduct electricity in the molten state and in aqueous solution because they contain ions that are free to move. In the solid state, ionic compounds do not conduct electricity because their electrons are fixed in positions in the crystal lattice structure and are not able to move freely. Covalent compounds do not conduct electricity because they consist of neutral molecules only. There are no free moving ions or electrons. For question 6c, ionic compounds have high melting point and boiling point because their ions are held together by strong electrostatic forces. A lot of energy is required to overcome the strong electrostatic forces holding the ions together. Covalent compounds have low melting and boiling point because the intermolecular forces that hold the molecules together are very weak. Only a little amount of energy is required to overcome the weak intermolecular forces. For question 6d, covalent compounds as solvents can be used to clean or remove stains that cannot be cleaned by water and to extract organic compounds. Now let us look at question 7. The table shows the electrical conductivity and melting points of substance P, Q, and R. Based on the table, we need to state the types of structure and bonding of substance P, and then explain the low melting point of P. Next, state the bonds formed in substance Q and R, then complete the sentences. The structure of substance P is molecule while its bonding is covalent bonding. It is because it does not conduct electricity in any status. Then P has a low melting point because the intermolecular attraction is weak. Less energy is required to overcome the forces to melt the substance. Based on the conductivity, substance Q is a covalent compound while substance R is an ionic compound. Therefore, covalent bond in substance Q is formed by the sharing of electrons, while ionic bond in substance R is formed by transfer of electrons, which produces positive and negative ions that are held together by strong electrostatic forces of attraction. So, R is soluble in water, while P and Q are insoluble in water. Next, question 8. The table shows the proton number of 3 elements. From the proton number, we have to write the electron arrangement of atom Y and the ion of atom Z. Then write the formula of compound form between element Y and Z. Next, state the physical properties of XZ form. Lastly, draw the electron arrangement of XZ4. In an atom, the number of protons is equal to the number of electrons. So, we can know the electron arrangement of the atom from the number of protons. The electron arrangement of atom Y is 2.8.2, while the electron arrangement of ion of atom Z is 2.8.8. Take note that the ion of atom Z will gain one more valence electron to achieve the octet electron arrangement. Since the charge of the ion of atom Y is +2 and the charge of the ion of atom Z is -1, the formula of the compound formed between Y and Z is YZ2. For the third question, we know that XZ4 is a covalent compound. Therefore, it has low boiling point and is insoluble in water. Other properties of covalent compounds are also acceptable. This is the electron arrangement of XZ4. Remember to check the number of electron shells and valence electrons based on the proton number of the elements. Question 9 gives us a table of elements with their corresponding electron arrangement. Question 9a is about the ionic compound. By looking at the electron arrangement of the elements, element V and Y are the elements that can react with each other and form ionic compounds. Since the valence electron for element V is 1, while element Y is 7, one valence electron from V will be transferred to Y. The formula of the ionic compound is EY. This is the electron arrangement of the ionic compound. Remember to draw the electrons properly and write the charges of the ions. Next, question 9b is about the covalent compound. The most suitable elements to form covalent compounds are X and Y because their number of valence electrons are not 1, 2, 3 or 8. Since X requires 4 more electrons while Y requires 1 more electron to achieve the octet electron arrangement, the formula of the covalent compound is XY4. This is the electron arrangement of XY4. As usual, check the number of electrons and label the atoms. Then, question 9c is about the inert or unreactive elements. Elements which are inert or unreactive is because they already have 8 valence electrons, which is the stable electron arrangement. So, the elements with 8 valence electrons are W and Z. To explain the unreactive property, we need to state that they have octet electron arrangement in their electron configuration. An octet electron configuration is a stable electron arrangement. Now, let's go through the last question, question 10. This question provides us a table of the atoms of 5 elements and their proton number. Question 10a requires us to complete the table. Question 10b, c, and d are about the ionic bond, covalent bond, and the electron arrangement. Please have a look at the questions. From the proton number, we can know the electron arrangement of the elements. The element arrangement of W is 2.5, X is 1, Y is 2.8.2, and Z is 2.8.7. For question 10b1, only the first electron shell will form the duplet arrangement. Therefore, X is the only element that can achieve duplet arrangement among the 5 elements provided. To form a molecule with triple bond, the elements must require at least 3 more electrons to achieve the stable electron arrangement, which are the elements with valence electrons of 4 and 5. Therefore, W will form a molecule with a triple bond. For question 10c, based on the electron arrangement, Z is more electronegative than Y. Z has a higher tendency to accept an electron compared to Y. Y has a higher tendency to donate 2 electrons. For question 10D and E, the type of bond formed between two atoms of V is covalent bond. It is because the electron arrangement of V is 2.6. It has 6 valence electrons. It requires 2 more electrons to achieve octet electron arrangement. This is achieved when 2 atoms of V share 2 pairs of electrons, forming a double bond. This is the electron arrangement of V2. Remember that there are 2 pairs of electrons shared, which is the double bond. For question 10E, this question is about the bond between atoms of Y and Z. The type of bond formed between atoms of Y and Z is an ionic bond. The reason is that the Y atom with electron arrangement 2.8.2 achieves the stable octet electron arrangement when it donates 2 valence electrons to form a Y2 plus ion. Z atom with an electron arrangement 2.8.7 achieves the stable octet electron arrangement when it accepts 1 electron to form a Z minus ion. Hence, 2 Z atoms accept 1 electron respectively from 1 Y atom. Ionic bonds are formed between 1 Y2 plus ion and 2 Z minus ions. This is the electron arrangement of the ionic compound. Note that there are 2 Z minus ions that have to be drawn and also the labeling of charges of the ions. This is the end of chapter 5. I hope you all enjoyed this chapter. Thank you and goodbye.